Imagine traveling millions of miles, only to face the most dangerous moment at the very end.
This is not science fiction. This is what landing on Mars truly looks like. Engineers at NASA call it the 7 minutes of terror. In those minutes, everything must work perfectly, or the mission is lost. Most Mars missions don't fail in space. They fail right here. Mars may look calm from orbit, but it is brutally unforgiving.
The danger begins with Mars's atmosphere, or its near absence.
Mars' atmosphere is only about 1% as thick as Earth's. Too thin to slow spacecraft safely, yet thick enough to create extreme heat. This creates a perfect storm for engineers.
Enter too fast, and the spacecraft burns up instantly. Enter too slow, and it crashes into the surface.
Even the entry angle must be nearly perfect. Just a few degrees off can end the mission.
At entry, spacecraft move at nearly 12,000 miles per hour.
In minutes, that speed must drop to 0.
On Earth, thick air does much of this work for us.
Mars offers almost no help at all.
The heat shield takes the first violent impact.
Temperatures can exceed 3,000 degrees Fahrenheit.
All of this happens without human control.
Engineers cannot steer the landing in real time.
Signals from Mars can take up to 20 minutes to arrive.
By the time data reaches Earth, the outcome is already decided.
Sensors constantly measure speed, altitude, and terrain.
A single faulty reading can trigger disaster.
There is no pilot, no joystick, no second chance.
Parachutes help, but far less than most people think.
These parachutes open while still traveling faster than sound. They are among the largest parachutes ever built.
Yet they cannot slow the spacecraft enough.
Rockets must ignite just above the surface.
Fire too early, fuel runs out. Too late, the craft crashes. Dust clouds can confuse sensors in seconds.
Every system depends on perfect timing.
Mars offers no forgiveness for mistakes.
Even the ground itself is unpredictable.
From orbit, landing sites look smooth and safe. Up close, they become fields of hidden danger. To survive this chaos, spacecraft must choose their landing spot while falling.
Cameras compare what they see with preloaded maps in milliseconds.
This system is called terrain relative navigation.
It helps spacecraft steer away from cliffs and boulder fields.
Even so, Mars still hides surprises beneath the dust.
A landing site can look solid, but behave like quicksand.
Too soft, and the spacecraft tips or gets trapped.
Too hard, and the impact can damage critical systems.
This is why landing legs absorb enormous forces.
Curiosity used a radically different approach to survive. Instead of landing, it was gently lowered on cables.
Seconds later, the sky crane flew away and crashed deliberately.
It looked dramatic because it had to be.
Perseverance improved this system with smarter navigation.
It landed within a smaller target area than ever before.
Even then, success was never guaranteed.
Roughly half of all Mars missions have failed.
Many were lost during landing alone.
Mars exploration has one of the highest failure rates in spaceflight.
Each failure taught engineers what not to repeat. Every success was built on lessons learned from loss.
And each landing pushes technology to its limits.
Humans plan to land much heavier spacecraft someday.
That challenge is even greater. Heavier mass means more speed, more heat, more danger.
Mars's thin atmosphere cannot slow large vehicles easily. New technologies are being tested to solve this.
Some ideas look almost like science fiction.
But physics always has the final say.
Mars demands precision, patience, and humility.
Yet we keep trying.
Because Mars holds answers we cannot ignore.
Did life once exist here?
Could humans one day survive on this world?
Every successful landing brings us closer to those answers. And every landing begins with terror.
"7 minutes, where physics takes control."
"7 minutes with no second chances."
When you hear a mission landed safely, remember this.
A machine crossed millions of miles and survived the impossible. Landing on Mars is not routine. It is one of the most dangerous maneuvers humans attempt.
And each success is a small miracle of science. Every Mars landing rewrites what we thought was possible.
Early missions failed because we underestimated Mars.
Mars is not Earth with fewer clouds. Its gravity pulls weaker, but still unforgiving.
Weak gravity complicates slowing down heavy spacecraft.
Too little drag, too much momentum. Engineers must fight physics with precision.
Landing zones are chosen years before launch.
But Mars can change between planning and arrival. Winds shift, dust moves, terrain erodes. What looked safe years ago may no longer be. That uncertainty follows every mission.
During descent, software makes thousands of decisions.
It calculates speed, tilt, altitude, and fuel constantly.
All within seconds.
There is no pause button.
Parachutes tear if stressed unevenly. Engines fail if dust clogs sensors. Radar can misread slopes as flat ground. Each risk stacks on the next. This is why landing is called controlled chaos. Touchdown itself is not the end. The spacecraft must remain upright. Solar panels or antennas must deploy correctly.
One failure can end the mission instantly.
Silence from Mars usually means something went wrong.
When signals returned, relief follows worldwide.
Because success is never assumed.
Each landing feels like the first.
Future missions will attempt even harder landings. Supplies, habitats, and eventually, South Asian humans.
Human missions leave no room for failure.
Systems must work not once, but repeatedly.
That requires breakthroughs still in development.
Supersonic inflatables may slow larger vehicles.
Advanced guidance may choose landing spots instantly.
But Mars will still resist.
It always does.
That resistance is what makes success meaningful.
Mars tests our engineering honesty.
It exposes assumptions and punishes shortcuts.
Only careful design survives. And even then, nothing is guaranteed.
This is why Mars landings still make headlines.
They are rare victories over physics.
Victories earned in 7 terrifying minutes.
Where South Asian humans can only watch and wait.
Hoping machines perform flawlessly.
When they do, history quietly changes.
Because every landing expands where humans can reach.
Mars remains dangerous, distant, and demanding.
And that is exactly why we go.
Mars is not just another destination.
It is a proving ground for human ambition.
Every landing attempts to tame a hostile world.
But Mars never becomes familiar.
Even after decades of exploration,
Each mission faces the same brutal physics.
thin air, high speed, absolute precision.
No atmosphere thick enough to forgive mistakes. No ground prepared to receive visitors. Only machines willing to risk everything.
Landing systems are tested on Earth, but never fully replicated.
Gravity is different. Air behaves differently.
And Mars adds uncertainty no simulation can remove. That uncertainty defines the danger.
When a spacecraft touches down, the silence is tense.
Engineers wait for the first signal.
Seconds feel much longer.
Then a signal arrives.
A machine has survived Mars's again.
Success is never routine.
Because Mars does not reward repetition.
It rewards preparation and restraint.
And respect for physics.
Future missions will raise the stakes further.
Heavier vehicles, larger crews, more risk.
Landing humans safely is the ultimate challenge.
It will require landing systems we are still inventing, slowing down tons of mass in thin air.
With no room for failure.
Mars will test those systems mercilessly.
Just as it has tested every mission before.
That test is unavoidable. Because landing is the price of discovery. Without landing, Mars remains out of reach. And landing is never guaranteed. This is why each attempt matters.
Each success expands human knowledge.
Each failure reshapes future designs. Mars demands patience measured in decades. And courage measured in minutes. Those minutes decide everything.
They always have.
Landing on Mars remains dangerous by design.
Because Mars refuses to be easy.
And that is precisely why it matters.
Mars forces us to confront the limits of technology. It shows how little margin for error space truly allows.
Every bolt, line of code, and sensor must perform perfectly. There is no backup planet during descent. Engineers design for failure before hoping for success. Redundancy is survival on Mars.
But redundancy adds weight.
And weight makes landing even harder.
Every design choice carries consequences.
Mars exposes poor trade-offs instantly.
This is why landing strategies evolve slowly. Proven ideas are reused cautiously. New ideas are tested relentlessly.
Because failure on Mars is final.
No spare parts delivered overnight.
Only one chance per mission.
That pressure shapes every decision.
It also sharpens focus.
Mars demands discipline, not optimism.
Hope alone does not slow a spacecraft.
Only controlled energy does. Entry converts speed into fire. Descent converts fire into control.
Landing converts control into survival.
That final moment defines the mission. Before it can explore, it must first endure. Endurance begins with those 7 minutes.
Minutes where mathematics replaces human instinct.
Where software acts faster than thought.
And where silence replaces control.
That silence is terrifying.
And absolutely necessary.
Because autonomy is the price of distance.
Mars reminds us how far away we truly are. And how small our machines remain. Yet those machines keep working.
They transmit data across millions of miles,
Turning danger into knowledge.
that transformation is the real reward.
Because Mars does not give answers easily.
It demands effort at every step.
Especially the first one.
Touching the surface.
Surviving the descent.
and proving we can reach another world.
That proof begins with risk.
And ends with understanding.
Landing on Mars will never be easy.
And it should not be.
Because difficulty is what makes it meaningful.
Mars remains dangerous.
And landing there remains one of humanity's hardest tests.
Every successful landing reshapes how we plan the next one. Data from Mars feeds directly into future designs.
Mistakes are cataloged, not forgotten.
This slow learning curve defines Mars exploration.
Progress measured not in years, but in attempts.
Each attempt carries the weight of every mission before it.
Mars does not reward shortcuts.
It rewards patience and discipline.
This philosophy guides modern Mars missions.
Landers are no longer just vehicles.
They are autonomous decision makers.
Trusted to act when people cannot.
That trust is earned through relentless testing.
Tests that still cannot recreate Mars perfectly.
Which is why uncertainty always remains.
That uncertainty defines the risk.
And the achievement.
When wheels meet soil, science finally begins.
Instruments deploy. Cameras awaken.
Mars reveals itself slowly. All made possible by surviving the landing. Without that success, discovery never happens. This is why landing overshadows every other phase. It compresses years of work into minutes. And exposes every weakness at once. Mars leaves no room for denial.
Either the system works, or it doesn't.
That clarity is unforgiving.
But it is honest.
Mars tells us exactly where we stand.
As engineers,
Log entry 42. We are making steady progress toward the northern canyons. The dust is proving challenging, but the rover handles it well.
And as a species reaching outward.
landing on Mars is never routine.
Because Mars never changes its rules.
Only our understanding improves.
Each mission sharpens that understanding.
Until one day, humans will land there too.
Carrying everything they need to survive.
Depending on systems proven by robots first.
That future rests on lessons learned today.
Lessons written during 7 minutes of danger.
Minutes that demand perfection. And rewarded with access to another world.
This is why we accept the risk.
Why we keep trying. And why landing on Mars still matters. Because beyond the danger lies understanding. And understanding is worth the risk. Landing on Mars remains dangerous.
And that danger defines the achievement.